Hello, good evening, everyone. How are you? I hope you are all doing well. And for this time, okay, this video will be about the development of atomic model, and alongside, I will be presenting to you the different proponents or the scientists who are involved in the different or um, in the development of the different models of theory of atom. All right, so we'll discuss atomic theory and the different proponents, the scientists, and how did they come up with this idea or the theory or the model of an atom. All right, so basically we will go through, okay, the different historical timeline, okay, from the beginning of when at the time when the first model of atom was presented to us by the scientists, and we'll also uh, we'll also try to understand how the different how the first model evolved from that concept until now. Okay, so we'll try to understand also. So basically, at the end of the lesson, you'll be able to complete this table, okay, and have a very good picture about, okay, the different model. Okay, for example, from the time of Democritus, Dalton, Thomson, Rutherford, Bohr, and Schrodinger and Heisenberg. Okay, so basically, we'll just discuss them one by one, the different models of theory according to their proponent or as proposed by the scientists. All right, let's begin with Democritus. It was 460 to 2060 BC before Christ. There are various basic elements from which all matter is made. Okay, that was according to Democritus. And according to him, everything is composed of a small atoms moving in a void. So it's like a blank space, parang siyang blank, and then uh, imagine like okay, a dot, okay, na yung mga particle, okay, that is moving in void, kanang space. And that is how Democritus described the atom. And some atoms are round, pointy, oily, have hooks, etc. Okay? So it was quite absurd, okay, to note that kind of observation from Democritus. But it's acceptable naman nga inaana yung observation because during the time of Democritus wala namang technology. Okay? Wala pang mga experiments na nakandak. So the way Democritus described how atom looks like during his time is justifiable. Okay, again, there was no technology. There is limited, okay, number of technologies during that time. And then um, next slide. Okay, the first concept of atom was actually given or proposed by Democritus in the year 400 before Christ. So this is how Democritus described the atom. It's just like a point. It's just like a ball or a very tiny um, point. Okay, in ana yung pagka-describe sa atom. Okay, that was according to 400. That was in the year or that was in the time or during 400 BC before. All right. The second person who presented idea about the model of an atom was John Dalton. Okay, he introduced the idea in 1803, and he said that an element is composed of a very small or tiny, extremely small particle called atoms. Okay, and this atom, okay, all of the atoms of a given element are identical, but they differ from those of any other element. For example, if you compare the atom of hydrogen to a carbon, they are extremely different. They are different. Okay, lahi sila. But when you check the hydrogen atom, they are the same. So that was his observation. And then atoms are neither created nor destroyed in any chemical reaction. So you cannot create or you cannot make a new one or a new atom because these atoms cannot be created nor destroyed as proposed by John Dalton. And a given compound always has the same relative numbers and kinds of atoms. For example, may compounds ka, the same ang number sa ilang number of atoms and the kind of atoms. Okay? And this is how Dalton illustrate his model. Okay, so he said that atoms are very extremely small particles or object. Okay, so you have there you have there the illustration of Dalton's model. It looks like that. Okay, and later on try to compare this model of Dalton to other scientists, okay, as we progress or develop from that year katong na discover ni Dalton up to this present. Okay, so you take note of the differences or the developments. The next person was J.J. Thomson in the year in 1940s. Okay, he died in 1940. He discovered in 1897. Okay, using a cathode ray experiment. Meron siyang ginawa na experiment. Okay, I will present to you the setup of this cathode ray experiment later on. Okay, and he proposed that an atoms resembles like a plum pudding model. Mura siya kanang pie, mura siya cake nga kanang na siya yung mga ginabutang bitaw nga, for example, blueberry cake na siya yung mga berry inside. And those berries nga katong nagrepresent sa cake, katong mga berries dito, it represent the electrons. Okay? Muna inakuan. Ano siya nga, ang atom is na siya yung mga subatomic particles. Dili lang kay atom-atom lang. Kung when you check daw the atom, it has subatomic particles pa dyan. Okay? Inside the atom. Okay? Napa doon siya electrons, napa doon siya protons. After he conducted an experiment, a cathode ray experiment. And then, in that experiment, the idea of plum pudding model was given birth. Okay, and this idea, it is as if electrons in a soup of positive charges. Katong gingon, wala daw siyang bowl, for example pie, tapos nakakigipamutang dito nga mga berries, for example, those berries nga on top of that soup or bowl, kay those represents the electrons. Okay, later on I'll be presenting to you how it looks like. And he also discovered isotopes in 1913. Okay, in a separate lecture, in a separate lesson, we'll be discussing also, or we'll be tackling isotopes. What are these isotopes? Now, what was the idea of Thomson? Okay, he actually conceptualized or thought of that his research has led to believe. Okay, according to him, my research has led me to believe that there are both positive and negative forces at work within the atom. Ano yung na-discover? Okay? Di ba before, when you check the Democritus and the John Dalton's model, okay, it was a whole lot different. Okay, lahig yun siya. Nga naman, wala pa nila nakita ang electrons o protons dito sa ilang model. Ang ilang na nakita dito, just atom. Atom lang siya. Mura siya atom. Kanang wala pa nila nakita ang mga subatomic particles. But it was Thomson who conceptualized that there must be something inside that atom. Okay, naging mga subatomic particles. And that is why he conducted this cathode ray tube experiment. Unsay gibuhat niya? Okay, nagkuha siya container, kanang kining cylindrical dira, okay, container. Okay, he took away the air. Okay, mura siya void, mura siya vacuum. So naka-enclose siya. Yang gibuhat, nag-connect siya og source, for example, battery, naman gyud positive terminal og negative terminal. Okay, gi-connect niya ang negative end sa battery sa isa ka metal. Kanang metal, let me have my pointer. Okay, this is metal. Okay, gi-connect niya na siya wire. Connection sa source, which is your battery. And then, the other positive terminal, another metal na pod, pero naibangag ang metal. Yang gibuhat, na-observe yan niya. Nga once daw, i-connect niya sa source, ang kining metal o kining another metal sa source sa battery, naday mag-emit nga light or ray. Okay? Kana siya ray, kanang makita niyo nga ray. Okay? And then ana siya, why not i-try na ako butang og magbutang ko og kanang charge connected sa positive o negative. Okay? Kung maapektuhan ba ang pagbend sa akong ray. So na-discover niya nga once butangan niya og charge diri nga na-connected pod siya sa negative og positive, magbend ang light. And he came to think, he thought of nga naay something sa atom nato nga maapektuhan sa negative og positive charge. Okay? And based on this experiment, ana siya, ang akong ray or ang electrons daw, okay, na this ray daw is an electron because it is influenced by the positive charge nga metal nga yang gi-attach didto. Okay, that was his idea. Okay, that was very long time ago. I'm sorry. And also after that, ano siya? Kung i-connect na ako ang kumutan na ako positive o negative charge, mag-bend ang light. Why not try na ako ang magnet? 'Di ba ang magnet makaapekto po siya sa flow of electrons. Okay. Ano siya? I-try na po na ako ang magnet. The same ang result niya. So, nag-conclude siya, nga ang atom is not made up of only one particle. Siya? It must be composed of an electron. Dapat ay murag naa siya electron because when you check the ray sa iyang experiment, nag-bend siya towards the positive charge. Okay? So, siya? Kining ray diri, this must be electron because electron is negatively charged and it is, okay, attracted to positive charge. So siya, ang atom, dili lang kay atom siya, mo na siya ka particle, it has subatomic particles na siya electrons. Okay, that was his experiment. And he came up with this illustration of plum pudding. Siya, an atom, siya, dili lang siya atom nga wala siya mga subatomic particles. Nagi siya subatomic particles. Siya, he proposed that, according to Thomson, siya, nga ang mga negatively charged nga mga subatomic particles, or we call it now electrons, naglutaw-lutaw siya sa positive soup. Okay, soup yung term na sa una. So we call this one plum pudding model. Okay, that was his idea. Now here comes another personality or scientist known as Ernest Rutherford. Ano yung contribution niya? Okay, later part ni siya sa after ni siya sa pag-discover sa plum pudding model. Siya? He proposed a nucleus theory in 1910 using an experiment, alpha particle gold foil experiment. And he said that an atom's mass is mostly in the nucleus. Siya? Naay mga naay structure sa atong atoms nga dito na concentrate ang mga subatomic particles. Okay? So, mo na yung giingon ni Rutherford. And then, he also said that the nucleus has a positive charge. Okay, di ba si si Thomson, siya dapat negative charge or electrons. Kinipod si Rutherford, yung giingon, there must be something positively charged. Okay, dili lang kay negatively charged or electrons. Okay? And he also said is electrons in a fixed orbit. Okay, naay orbit daw nga gina-follow ang electrons. Okay, let's check the model. This is what the setup of alpha particle experiment. Ang gibuhat niya diri, just to give you the idea of how this experiment was conducted by Rutherford, yung gibuhat nagkuha siya og kanang radioactive element which has the ability of emitting alpha particle. Yang gibuhat nagkuha siya gold foil kaya ang kanang mga radioactive nga mga element, they can able to release alpha particle because they are radioactive. Yang gibuhat nagkuha siya gold foil. Di ba ang gold man na siya? It's an element, so therefore it's made up of atoms. Okay. Ang yang gibuhat nagbutang siya og gold foil surrounded by detecting screen. Ang iyang naobserbaran, ang alpha particle naga-pass through ang uban naga-bend, ang uban naga-bounce back. And that gave him an idea nga ang atom, for example, this a gold foil, okay, must have something inside or nasa center niya nga concentrated siya. Kay nga naman, kay kung walay concentration in the middle or in the center of the atom, dili mag-deflect, dili mag-reflect ang mga rays sa alpha particle. So, there must be something inside that atom nga makaapekto sa behavior sa pag-reflect, deflect, o sa pag-bounce off sa mga alpha particle. And that presented us the idea that in the model or in an atom, there are subatomic particles which are concentrated in the middle or in the center of an atom. Okay, that was the idea of Rutherford. And he said also that outside, circling or orbiting the concentrated subatomic particles are actually electrons. So this is how Rutherford illustrate the model of an atom. Okay? 'Di ba makita natin siya usually sa mga videos, sa mga illustration. This is very common nga model, 'di ba? This is the model of Rutherford. Okay? Ano siya? There must be some subatomic particles which are concentrated inside or in the center of an atom, and there is that electrons which are orbiting outside that concentration or concentrated subatomic particles. And here comes another personality in the person of Niels Bohr. Okay, it was in 1913 when he proposed the planetary model. Okay, he said that the nucleus surrounded by orbiting electrons at different energy level. So, ano siya, di ba, kay Rutherford ganiha, ang electrons na cloud or na mga orbits outside that concentrated area or the central, or the nucleus. Ano siya? Si Bohr po, ano siya? Kanang mga electrons nga nag-orbit, it has or it occupies a level. Okay? And we call that energy level. And that electrons have definite orbits. Okay? And Bohr utilized Planck's quantum energy theory. Okay, I will not explain this in detail because this is higher physics already. But anyway, he worked on Manhattan Project known as US atomic bomb, kining si Bohr. So this is how Bohr model looks like. Ano siya nga? We have nucleus and we have the protons inside. Okay, sa pinakatunga, the nucleus, it has protons and neutrons, while outside that protons and electrons or the nucleus, makita nato ang mga orbits of electrons, and some of the electrons are occupying certain energy level. For example, this is first energy level, second energy level, and so on. Okay? So the idea, now the illustration of Bohr model looks like this. So we have positive charge, we have also the neutral charge, the neutron, and surrounding that neutron and protons are electrons, okay, which occupies a certain level. We have the first level, the second level, energy level. So yun yung model ni Bohr. All right, and on the latest development of model was proposed by Ernst Schrödinger, okay, and Werner Heisenberg. Okay, so we have already the quantum mechanical model, which was proposed in the year 1926. Okay, and they said that electrons are in probability zones called orbitals. Na natin mga orbitals, not orbits, and the location cannot be pinpointed. Electrons are particles and waves at the same time. Okay, and develop quantum number based on theories of Einstein and Planck. So this is a bit complicated now, okay, from the Democritus nga idea or illustration or model of atom. Now this time we have this kind of atom na model of an atom. So we have the different orbitals. That is why 1s, 2p, 2s, 3s, diba, itong chemistry. We will not discuss that in detail because I am just presenting to you the different models of an atom. All right? And here, the quantum mechanical theory, the electron in a hydrogen atom. Okay, so this is the actual photograph of an electron in a hydrogen atom. Okay, so we have, with the advent of technology, we have with the available, with the latest or high tech the technology, we can actually um, observe, okay, the formation or the structure of atoms, including the subatomic particles. So to sum up everything, we have this atomic theory. Okay, it has developed from Democritus time up to this day. Okay, so we have Democritus. It was eventually changed by John Dalton, and we have also J.J. Thomson coming in. We have also Rutherford, Niels Bohr, and the present now we have Schrödinger and Heisenberg. So all these personalities or all these peoples help us understand better how atoms behave, the structure of atoms, including the subatomic particles, the protons, the positively charged subatomic particles, the protons, the negatively charged subatomic particles, which is electrons, and the neutral charge, no charge, which are the neutrons. All right, thank you very much. I'll be posting activity in the Teams. I hope you will um, answer all the questions that are required in that activity. Thank you.